everyone, and welcome to the first video of our macromolecules module. This video is going to focus on the predicting bonding that can occur between elements that we discussed in the previous unit and are actually working with this unit. Alright, so just a reminder of what we went over last time. Last time we talked about how the periodic table is a tool useful for predicting the bonding that can occur. Now, we needed to know how the tool works. So, remember that instructional menu that you made? You created a cheat sheet on how to use that periodic table as a tool. We investigated in how they even came up with the initial structure of the periodic table and even visited some previous models of how they got to the modern periodic table. Now, the groups, which are the columns of the periodic table, we focused on groups 1 and 2, which are columns 1 and 2, then groups 3, 4, 5, 6, 7, and 0, which are columns 13 through 18. Alright, so we skipped that transitional metals, and so you'll need to remember that it's 1, 2, skip a few, and then continue on with the 3, 4, 5, 6, and then group 0, because 0 does not react with anything. That means it is inert, and the noble gases are just too good to do any other bonding. So, these groups tell us the behavior of the atoms. So if you look back at that instructional menu, the examples that I put on Canvas, what you will see is that group 1, the behavior says that it's going to give up its 1 electron, because group 1 means it has 1 valence electron, or 1 electron that's found in the outer shell of that atom. It goes on to where group 2 has 2 in the outer shell, 3 has 3 in the outer shell, and on and on. Now, the importance of knowing how many electrons are in that outer shell, or how many valence electrons, is that's going to determine what it wants to bond with. So, atoms want to create bonds in order to complete their outer shell. Now, we've only discussed the first 2 orbitals at this point. The first orbital we said only holds 2. It's the old married couple that stays inside. It's too close to the nucleus to have room for any more. So remember, first orbital has 2. Then the second orbital holds 8. And we said it's the perfect party size. You have to have 8 to be considered a party. And so we want to complete that 8. So if we have a low number of valence electrons, we want to give them to somebody else and let them spend more time over there. But if we have a lot, we're trying to recruit people to our party. So when we first started talking about these bonds that can happen, we did this PowerPoint on bonding basics. And then we did our activity where we used the Play-Doh to be the atoms, and then the toothpicks to be the bonds. So let's just review a few things from here. So we had to remember that there are 2 types of bonds. So an atom that gains electrons has a negative charge because electrons are negative. And so we looked at the opposite of that, where the atom loses an electron, that negative charge has gone away, and it leaves a positive. Now, the reason it's important to know about these 2 is because we make ions when we gain or lose electrons. Of course, it's science again, so we have to give them these names. So the positive ion is the cation, the negative ion is the anion. So the way we talked in class about how to remember these was the cation is positive, and cat videos are fun to watch, so it's a positive, so cation, positive. Then the negative ion being the anion, we just had to go with the, if you put an A in front of anything, like abiotic, it means not alive. And so not is a negative word, so we get negative ion from anion. So, the reason we care about these ions in this bonding basics talk is that ions form ionic bonds. And so this is where they're actually giving away these electrons. So, we're transferring atoms from one form to the other. We are completing the outer shell. And the ionic bond is forming between metals and nonmetals. So if you have a periodic table on a test, which you always will in my class, and you don't know what kind of bond is being formed, you can look at the classifications on your periodic table and say, oh, I have a metal and a nonmetal. must be an ionic bond. So this is the example. We've joked about how you all say salt way too much, and so sodium chloride is our salt example. And what you see here is that there is this extra electron. Okay, so sodium is in group 1, means it has 1 electron in its outer shell. Right, so that's 1 valence electron. Chlorine, on the other hand, has 7 valence electrons. And so together, they can make a perfect party of 8. But first, sodium's electron has to travel all the way over to join chlorine. So we end up with a cation, or a positive sodium ion, and an anion, which is a negative chloride ion. And so chlorine has an identity crisis when it gains that extra electron. It goes from chlorine to chloride. That won't be on the test, just a convention you'll need to get used to. So then we make our sodium chloride, and you have salt. Now, the other type of bond is covalent. And covalent is the type of bonding we are dealing with right now in our macromolecules unit. And so this is where atoms actually share their electrons. Each atom is still trying to get that complete outer shell, but this time the bond only forms between nonmetals. So this picture here shows how they are sharing the electrons. They belong to both hydrogen and carbon in this case. And this is our methane, or in cruder terms, I guess, a fart. So we also can share more than just those 2 electrons. So in the previous slide, you saw that there are only 2 dots being shared between each of these atoms. And so that's 2 electrons, or 1 pair. We can also share more than just 2. Now, if we're sharing 4 electrons, we're sharing 2 pairs of electrons, which makes it a double bond, like in this picture and in this picture. But we also can have a triple bond, and that's where we're sharing 6 electrons, or 3 pairs between them, in order to complete their outer shell. Now, we don't just make double and triple bonds just for fun. Again, it's so that we can complete that outer shell and have the perfect number of valence electrons. All right, so we practiced that with the Play-Doh before. If you weren't there that day, you missed out on some fun, but you can still keep going with us. So, the next thing that we did so far with this part of the unit is we looked at the scale of the universe. And so with the scale of the universe, we got this fun background music going on, but you were actually able to see why we care about things this small. So here's our human, okay? Here's us, that creepy giant earthworm that we saw. But we also keep going down smaller and smaller, past our bacteria, past those viruses, all the way down, past our macromolecules. See, there's some macromolecules showing up, all the way to atoms. All the way to our nucleus, protons and neutrons, the classical electron. But most importantly, we are looking at these molecules that are being made right now. Alright, so this was just so you can recall how tiny what we're talking about really is. So it's hard for us to visualize these things, so that's why I'm giving you some visual aids like the Play-Doh. And then we went on to do the atom game. And so the atom game was where I assigned our molecule leaders. They had, like, H2O was one of our examples. Then we gave out the atoms to other students. The molecule leader had to go collect their people, put them together, and figure out how many bonds were required in order to determine a complete outer shell. Alright, so some of those rules again, we will focus on looking at this periodic table. So, when we were in group 1, we only have 1 electron, and so you were wanting to give that 1 electron in order to make an 8. So, these 1s are usually very happy with these 7s, because together they can make 8. But also with our H2O example, we can have oxygen, which is 6, and it can take 2 hydrogens in order to make its perfect 8. Alright, So, the big question you all always want to know is, why do I need this? And so in this case, in the macromolecules unit, you need to know about bonding because macromolecules are the building blocks of all living things. You are just bunches and bunches of macromolecules held together. Macromolecules are actually made from those elements found in living things that we studied before, and they are simply those elements bonded together, usually covalently. Now, the next video that you're going to need to watch is about the 4 types of macromolecules, and that is the nucleic acids, the lipids, proteins, and those carbohydrates. I hope this was helpful, and I will see you next time.